Occasionally, the equation for an ellipse is not written in a nice form, although it may appear very friendly. So for example, 4x squared plus 5y squared equals 20 is the equation of an ellipse because it has x squared and y squared, and there's a plus between them. Okay, but it's not in a nice form because, for example, we typically like for this side to be a 1. Okay, so what is a nice form of an ellipse? What we'd prefer to see for any ellipse is x squared over some number plus y squared over some number equals 1. And so these numbers here are important because the square roots of them tell us the distances to measure from the center of the ellipse. Alright, so let me motivate some ideas here. We should all understand that if I take 4 divided by 2/3, that is simply the same thing as 4 divided by 2/3 is the same thing as 4 times the reciprocal of 2/3, 3/2. So my point is, when you divide by a fraction, that's the same thing as multiplying by its reciprocal. Well, for that matter, when you divide by any number, it's the same thing as multiplying by its reciprocal, right? So 4/5 is the same thing as 4 divided by 5, which is the same thing as 4 times the reciprocal of 5. So those two things are the same as well. But it's a bit more useful. We find this property a bit more useful when we're dealing with division by a fraction. What I'd like to do at this point is get you to think about using this property in reverse. Multiplying by 3/2 is the same thing as dividing by its reciprocal 2/3. So we'll actually be using that property here. Okay, so let's take a quick example of this. Let's say that we have 2x squared. So x squared is being multiplied by 2, and what I'd like to have is x squared divided by something. Well, x squared multiplied by 2 is the same thing as x squared divided by the reciprocal of 2. Okay, so that's pretty simple. And another example might be something like 5x squared over 3. This is the same thing as multiplying x squared by the 5/3, right? X squared could go on top or out to the side. It's the same thing. So I'm multiplying x squared by 5/3, but what I'd like is x squared divided by something. Well, it would be the reciprocal of 5/3, which is 3/5. So let's look at how this applies to the equation of an ellipse. Here we have an equation for an ellipse, and it's almost in a nice form because we at least have the 1. But our goal is to have it as x squared over a number plus y squared over a number equals 1. So the point is, this 4 can't be there, right? Because I can't have a number in front of the x squared. So what I'll do is I'll think about x squared as being multiplied by 4 here. That's the same thing as dividing x squared by 1/4. So 4x squared is exactly the same thing as x squared divided by a 4th. I didn't divide both sides by a 4th or anything like that. I simply rewrote 4x squared as x squared divided by a 4th. And y squared, if I want y squared over something, well, y squared could be put over 1, and that's exactly the same thing as y squared. So those two things are equal as well. Finally, equals 1, and now we have the desired form, and we can use the numbers in the denominators here to measure out from the center of the ellipse to graph it. We could also use these numbers to find the foci.